This Apache runs on which port?
80.
80. And assume this is the PID number 50. And then they're writing a file in, let's say, OPT Apache. I'm just for visualization, I'm writing it. Please understand, OPT Apache. Now, other user, do you think he'll be able to use 80? Other user in the same machine?
No.
No. Why no? Because of only one network. Correct now? And do you think this PID 50 he can get it? No. Why? Because there is only one PID tree, and the PID tree always create a unique PID. So it is, if it is a 50, it can be 51, 52, whatever it is, not 50. And if you write up files of this Apache also in OPT Apache, don't you think this integrity of the file will be compromised? So no 80 port, no 50, no this one, what do you say? OPT Apache. And the same conditions we have with this also. Are you understanding now? There is a problem?
Yes.
So guys, now you are thinking about yourself. Now think about the data center. Think about a data center. Why you are not running? Think about it. Why you are not running multiple Apache in the same VMs? Think. Because of isolation is not there. Resource isolation. Some official keyword is resource isolation. Technical keyword is PID tree, network, MNT. These isolations are not there. Users. You can't create a two users in the same machine. Same user. So this is not there. So what they need to do, what they usually do in the data center, they do simple thing. They say, hey, I will run only one user in each VM, and they do something like this. This one. See, are you agreeing with me in the data center? Yeah. Correct. Now you, all of you are understanding that, right? All of you?
Yes.
Yes.
Now you tell me if you have understood this situation of data center. Remember, cost reduction required not in your laptop. Cost reduction required in the data center, because most of the applications nowadays you are accessing from the cloud base. Google, LinkedIn, Twitter, Insta, what else? HDFC Bank, ICICI Bank, Ola, Uber, WhatsApp. Everything is running not in your laptop and not in your mobile. It's running in the data center. And they're consuming lots of resources. All these applications are free. Data center cost is growing, salaries are growing, electricity cost is growing, infrastructure cost is growing, AC cost is growing. So how can we reduce the cost? That's what I was talking about here. How can we reduce the cost? Now, another perspective. See, let's say if Ola is down for 5 minutes, 5 seconds, sorry, what you will do? Quickly.
Uber.
Uber. Second time is down, Uber. Third time you will go to Uber directly. Ola has lost the customer because of 5 seconds of downtime. That is what we don't want actually. There is a problem in the software. We have to immediately roll back within a second. It's all about the second game now. No 5 minutes, no 1 hour, not 2 days. Earlier, Microsoft used to tell, I will fix that issue next year in the next release. If Ola will say, I will fix the issues in next day, they will become a bankrupt. Are you getting my points, what I'm trying to say?
Yes. Yes.
So the problem you have here, tell me that in this whole model, what is the problem for the companies who's running application? Tell me, this is a problem area. This is the problem area. Tell me.
Getting the services back on another VM is going to take a lot of time, which is going to directly affect the business.
Correct. That's one problem. Second problem in terms of cost, please tell me.
Resource consuming.
We are using hardware, different hardware at different places.
See guys, let's say if you run 100 of boxes, 100 of VMs in simple way in a production, that means in a simple way, you are running hundreds of operating system, don't you?
Yeah.
Remember that each operating system also consume CPU and RAM and storage and licensing cost. So the idea here is, the problem on this here, see, the cost is increasing. Why? Because the CPU, I mean, this operating system, so let's say you want to run one application, two applications, three applications, four applications. So four applications, you want to run four operating system, four operating system. Each operating system also add a CPU uses, RAM uses, infrastructure uses, boot time, and all this blah 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 blah. So that's a problem from last 15 years we are having with the virtualization technology. So problems you understood for the today's technology, all of you? All of you understood?
Yes. Yeah.
Yes.
Can we solve it? So guys, let me try to solve it. And think each one of you as a architect and understand that all these points we have discussed by the way. Okay, there's nothing left actually. Discussion is over. Okay, now only demo time. You should tell me, how can you save a cost? Forget about the container. How we save the cost? Tell me. This is the hardware. So here, my suggestion would be, look at this table. Very important table. I said multiple times, please do not ignore this table here. How many users can we create in Linux kernel, and how many pit tree, and how many network, and how many mount, and mount means what? Root file system. So can we do something like this? Think simple, okay? Can we do something like this? This is a user. Can we do something like this? Are you getting me what I'm trying to say? Tell me. Can we do something like this?
Yes.
All of you.
Yeah.
Why? Because kernel is having capability, correct now?
Yeah.
So kernel can create multiple mount. See, think simple. Here kernel is creating mount 3, wonderful. 3 network, wonderful. 3 PID, wonderful. PID tree, wonderful. 3 user, wonderful. Now you know here, look at this. This user is getting their own PID tree, their own network, their own mount. This user is getting own PID tree, own network, own mount. This user is getting own PID tree, own network, own mount. But traditional way, what was that? Traditional way. See here, all users getting only one PID tree, one network, one mount. Tell me, are you understanding now?
Yeah.
So we have to come out of the traditional way. Earlier, see, you go in your laptop, you create a number of users, you will still have a C drive. You still have that same network, all users will access. They will access the same PID tree. That's the problem. Isolation cannot be created. So to create isolation, they started creating a different VM. But actually the answer was hidden somewhere here in the kernel. Kernel allows everyone to be created multiple PID tree, multiple MNT, and multiple user. So why can't we do this? That means, see here, very simple. Let me copy it from the here. Very simple. Look at this here. These applications you want to run in this one here. Here, see here. This user can run their own Apache 80 port because their network, this is separate. 50 pit tree because they have got their own pit tree, and then different mount, which is a OPT Apache. This guy also got the same thing. This guy also got the same thing. See, the isolation is done. Are you having positive thoughts about this architecture? All of you.
Yeah.
Yes.
Okay. So if you think so, yes, this is what. There's a one guy, and his name is Solomon Hikes. He's the one person. This is what he's thinking also. He said, hey, why we are running multiple operating systems? It's a waste of resources. Can't we work with the kernel level and isolate the resources itself? I did the same thing. It was not my idea, it was his idea. By the way, to be honest, he's the father of Docker, but this idea was there since in a this one, what do you say? There's a supercomputers and all, it was there actually. I forgot that stuff. Mainframes and all, it was there and earlier also. But this guy made it so easily available for all of us. So we say it's a father of Docker. So Solomon Hykes say, hey, why don't we do this? Talk to kernel, create an n number of mounts as attached to each users, and each user will become isolated. And they can run their own environment, and applications can be run independently. There's no problem. So all applications can run native port, 50 PID, and OPT Apache. Super. So then you know what has happened. Linux says no. Windows first said no, it's not possible. It's not, I will not allow. It's not possible. They never said. They say I will not allow do this. Linux also say I will not allow do this. Why they said no? I will not allow at the kernel level.
Their market is going to sink.
Yes, right. Yeah.
By less number of OS licenses.
That's correct. Yes. So they said they will not allow because of the same reason you said. Then Linux is open source. Actually, must understand that. So Docker said, Solomon Hykes said, no problem. Linux is open source. I will make my product also open source, and any open source can integrate with any open source. Understood this problem? Understood the solution?
Yeah.
So what they said, hey, I don't want to disturb you as a core, Linux core. What I will do, I will create one layer on top of it. Layer on top of it, somewhere on top of this layer. Okay, understand? And this layer, see, I will not interrupt you how you used to work and all. I'll let it be. The way you used to work in Linux operating system from last 30, 40 years, whatever it is, let it work. I don't want to disturb you. But you know what? I will build one layers on top of your operating system as application. They said, hey, Solomon Hykes asked Linux community, can I install one application? Then Linux community started laughing, saying, hey, what you're talking about? You can install very well. You can install any applications on the Linux. Then this Solomon Hykes said, okay, my applications will read kernel. Will you allow? That is where that they say, no, you will make it the operating system unstable. So what do we do in this case? What do we do in this case? Then Solomon Hykes said, hey, listen, you guys are allowing some libraries to access the kernel. Which are the library? Look at my screen. Libvit, these are the open source. LXCs, systemd, spawn, nspawn, and all stuff like that. So these library can access this. Now it's a containerd, okay? Mind it, containerd. So then in that case, they can allow, because it's how this open source is designed. Everything should be in a modular. Then you know what? Docker started using these libraries to access what? Kernel. And Docker said, hey, I need to create one mount, one network, one pit tree, one user, and then attach this all the resources to this user. Create this all resources and then attach to this user. Are you understanding? Who's instructing? Docker, with the help of what? All these library. Now it's container debugging. Okay. Are you understanding now?
Yeah.
So the final question, guys, what is a container? Did you understand, all of you? Anyone who could understand what is a container?
Resources, application.
So guys, there are two definitions I must tell you. Container is running your app. You see that image? This is the app. But with their own resources, their own independent resources. Okay, resources means PID tree, network, MNT, user. But this is a functional definition. Technical definition, if you say, container is having, okay, mind it, one user from user namespace, one network from network namespace, one mount from MNT namespace, and last one PID from PID namespace, PID tree. And altogether, this user attached to this network, this mount, this PID, and that's become a container. Requested by Docker to container D. See, this library has been renamed recently, this LXC and all, container D, and then container D asks this to kernel. And kernel can do all this resources creation. These are technical definitions. So guys, did you understand that this container is lightweight? Why? It's lightweight because container is the only thing. If you look at this architecture again, container has a no boot. See that? Container has no boot. Container has no boot. See here. So container only start with a root. Are you understanding?
Like the container is a non-editable or single-time create. If you want to edit in future.
Let me ask you one thing. How many times you can create a user? N number. So you can create n number of containers. How much time it takes to create a user? Second. So container will be created in a second.
We need to destroy if we want. We cannot edit the existing container. If any resources, additional resource want to increase, edit the existing
you can
container.
Edit. You can edit. You can edit a container. No problem. Okay, so all of you understood what is a container now? Any confusion?
You explained in very detailed and different way. I even had many different introduction sessions. This is awesome. Great.
Yeah. Yeah. So this is the official definition. Container is a lightweight application runtime environment independent with independent resources. Simple. But actually this is the architecture. Okay, so container is lightweight. Why? Because it has no operating system. It has just a root file system. So what is a container? What is a Docker? Yes, it's a container management tool. It's a container management tool. You have a multiple releases actually. Okay, it's a multiple releases. One is a community one down, which I'm talking about, but we have enterprise also. Okay, community one also is a free and open source. Now this is also, by the way, free. You can use it, but not open source. You can find this other features also. Now this is from the company called Docker. Okay. Now they have a latest release, if I'm not wrong, 20x. Okay. And this tool is written in Golang. Written in Golang. Okay. So what is Docker? Why do we need it? And what is a container? Everyone have got a clarity? All of you?
Yeah.
Okay. Now next thing is architecture of Docker. Okay. So there are few places I might do the spelling mistake. Please ignore it. So what is architecture? So first, in every architecture, we are human. We talk to the Docker client. Okay, Docker, the command which you run is a client. Okay, Docker client talk through APIs. Okay, and then reach to Docker server. Okay, this we call it a Docker D also utility. Docker D. This is utility Docker D and Docker client, which is Docker. Okay, through API they talk to each other, and after this Docker D talk to the container D, because they cannot directly communicate. And after that, container D talk to the kernel, and then entire things is empowered by this. All entire things is empowered by kernel based upon the request from the Docker human. Did you understand, all of you? All of you? Now, guys, here you see that client and Docker D, they can talk through API. So think theoretically, if they can communicate with the API, can I keep this client and Docker D in the separate machines?
Yes.
Yes, we can. We can. So yes, this is possible theoretically. So please understand that way. So what is a container D? Then you'll ask. See, I'm not getting into too much of deep dive into the container D, but you can read only few statement, and I think it should be enough for now. Okay, because each tool itself is like lots of things. Only read this much. Not don't need to read too much. It's an industry standard container runtime. That means anyone who wants to talk to kernel for the container requirements, they can use a container D. That means Docker is not alone which can create a container. There are tens of tools are similar to Docker. Okay, so Docker is one of the popular tools I'm teaching you now. We have a tens of tools which can manage the container with the help of container D. Anyone who talks to the kernel, they can use as an industry standard container runtime environment. That's called container D. Are you understanding? All of you?
Yes.
Guys, container D is available in Linux and Windows also. So right now I'm teaching you Linux, but it's supported in the Windows environment also.
Container D is already bundled into the operating system, or it's a separate package?
See, most of the time it is coming, but if it's not coming, when you install the Docker, you'll get it along with it.
Okay.
Okay, so now you understood this, but you know, guys, this we call it, this things together, this one, we call it a Docker engine actually. Okay, this is the first software of the company called Docker. See, whenever people talk about Docker, everyone is talking about Docker. Actually, Docker is a company name. It's not a product name. It is a company name, not a product name. So when people say Docker, that means they are talking about Docker engine. Docker as a company have multiple products. Docker engine is the first product. Docker Swarm, Docker registry, and many other tools they have actually. Many other products they have. Are you understanding, all of you?
Yeah.
Yes.
Okay, so now next question what we have, and that is how to install Docker. So guys, Docker you can install in Windows also, Linux also. As part of this demo, I will use CentOS 7 because I'm using for all of your sessions CentOS 7, but it can be installed in Windows, SUSE, Linux, or any other flavors of Linux also. There's no problem. So how to install Docker? So right now I'll get into the demo after what, why and how. Let me create a one VM quickly in front of you. CentOS 7, I'll just go for it. CentOS 7. And where's this marketplace? I'm buying this MIs, and continue. I'll go for the demo a little bit, so it should be faster. So I'll go for the little bit of, let's say, 2 CPU for 8 GB RAM. So my demo will be little faster and can save some time for the Q&A also. Okay, so here, this is the tag, Docker, and security groups. I'm opening up everything, default, launch, and key I'm having it Rajesh Mumbai, and launch. So this is a machine VM. This is a VM I got it. Remember, it's a cost. If you run an application in a VM, it's a cost, because you have every VMs you need operating system, which consumes CPU, RAM, and stuff like that. Booting time also is a little bit more. So please understand that. So guys, can you see my screen, all of you?
Yes, I can see.
Yeah. So guys, here I'm going to log in to the Linux VM. And now the question is, where is the tutorial for installations and all? I think by now you know that every resources, I keep it at my blog site, and that is somewhere here. So any tutorials, if you want to search for it, please go and search for it. So I'm just searching like UN here. So here I'm searching Docker install. Docker install. Here you have 4,000 tutorials, so which will help you. If you don't find some of this stuff, please ping me over there. I'll try my best to upload it as soon as possible. So guys, there's a hell lot of installation instructions are there, and ways are there, methods are there. I'm not going to complicate and waste the time. One of the method, I'll just pick it up blindly and then install it. Again, you have a recordings, you can check it out. You can do slowly, and if you don't understand anyways, WhatsApp groups are there. So I am installing the Docker using the scripting way, and there's a problem here. Problem is I'm not logged in actually. Sorry. So yes, now see guys, here done. So I'm installing, sudoing and executing, and finally this command to enable it for the tomorrow, which we don't have right now. Next, reboot. Many ways to install Docker actually, so don't worry about that. The ultimate goal is should be having Docker running, that's all. Which we install through executable, through RPM file, through ribbon file, through script, through some APIs and all, is none of these things matters. So it's an installation in progress. Can you see my screen, all of you?
Yes, you can see.
Yes. So yes, here I'm enabling it, though it's not required, just running for the sake of demo, and starting it, that's required for now. And guys, the moment Docker is installed, first command you should run Docker info. That's the first command, okay? And here you see, it says, hey, Docker, blah, blah, blah. So this error is available. Why? You see that permission denied. So that's where I want to show you some error. Remember that, what is the user CentOS? What your command you are running? Docker info, any command for the sake of it. So why this CentOS is denied with running the Docker command? And the reason is very simple. Docker can be run. Please hard code this statement in your mind. Very important interview question. Docker can be run with the root user or sudo or this last point, if the normal user is a part of the group called Docker. Last one you understood? If the CentOS user is a part of the group called Docker in a system, then he can run it. Or you become a root or whatever it is. Did you understand all of you?
Yes.
Yes. So now I'll become a root just to make it easier things. I don't remember the sudo all the time, but yes, if you want to make it, if you want to run it as a CentOS, you add group called Docker, add this CentOS into the group called Docker, and then run it, no problem. You have to re-log in, by the way, so please remember. So Docker info is a command which I'm going to run it and see that.
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to hundreds of playlists and 1000s of videos lifetime access with this membership. Enjoy.
Thanks for watching. Want to study further? Join our training programs today.